Okay, so we're going to be covering quadratic relations. Yesterday we went over nonlinear things. The first thing we're going to be going over is what the equations tend to look like. So we have y is equal to ax squared plus bx plus c. The a, b, and c are all variables that represent any number essentially. Okay, so you could have a relation that looks like this. Maybe, in fact, we'll use one of them. We'll use this one here, 2x squared plus 3x minus 1. Let's see if we can figure out which variable stands for which. What would be the a in this case? 2. What would be b?
3.
Yeah. And what would be c? -1. Okay. So those would be our a, b, and c in a quadratic relations. That's going to become very important as we go through things. If you guys remember when we were doing factoring, we were looking at these exact types of relations and we were factoring them. There's a reason to why we were factoring them, and we're going to relate it to how it looks on a graph later. Now, first thing is a graph of a quadratic relation is called a parabola. Okay? So I'm going to draw one here. So this would be an example of a quadratic relation. In fact, this would be an example of this exact quadratic relation, nothing else involved with it, just y equals x squared. Okay? Now, there's a couple things we want to touch on. This graph is called, anyone remember I mentioned it yesterday? Starts with a P? Parabola. Okay? This is called a parabola. Secondly, parabolas have maximums or minimums, not both. Okay? Now, because this parabola is opening upwards, if you notice it goes upwards, the parabola, that means it has a lowest point. In other words, it has what we could refer to as a minimum. Okay? The lowest point is right here. We call it the minimum. This point itself is also known as the vertex. Okay, very important. The vertex is very important. There's a coordinate for it. In fact, this coordinate is 0 and 0 just so happens to be. That's the x and y value of the vertex. The minimum value of the vertex is equal to the y.
She said that.
So the minimum value is also known as the y value of the vertex. In this case, the y value of the vertex is 0. So the minimum would be equal to 0 in this case. Okay, y is equal to 0. There's another part of a parabola. It is a symmetrical shape, and it's cut right in half by an imaginary line going through the middle. Okay, this imaginary line actually goes through at the x value of the vertex. Okay, the x value of this vertex happened to be 0. So the imaginary line is called the axis of symmetry. And the equation for that axis of symmetry would be x is equal to 0 in this case. It's a vertical line going through it. Okay? These are all important definitions you need to know for when we go through parabolas, because we're going to talk about axis of symmetry, minimums, vertex, and a couple other things with it. Okay? Now, I'm going to make another imaginary one here. This would be rough to do. Down here, sorry. Okay. Here's another type of parabola. Okay. We're going to quickly talk about this one too. First of all, this highest point is what? The vertex. Okay, that's actually a 4 over here. Okay, yeah, right. This is the vertex. What's the coordinate of this vertex? Good. -8 and 4. All right. Is this a minimum or a maximum, this vertex? A maximum. It's the opposite, right? It would be considered the highest point of the parabola. So this is a maximum. The imaginary line going through the middle of it is called what? Okay. And the axis of symmetry happens to be what in this case? Yes, so x equals -8 is our axis of symmetry. We'll call it the AOS. Okay. Now what's the max value? We don't use the -8. We would just say y at 4. Okay? That would be our max value. Okay? It's the highest y value that it gets to. So we talked about maximum, vertex, Axis of symmetry, good. Okay, so these are some major points we need to remember of parabolas when we're going to graph them. Another thing we need to figure out with a parabola is something called differences when we're looking at a table. So we're used to sometimes looking at tables, okay, where they give us an XY table with certain values. Okay? And we need to figure out if something is quadratic or linear. Well, we can look at this equation here and kind of figure that out. Anyone know what type of relationship this is? Linear or quadratic?
Quadratic.
How do we know it's quadratic?
It's squared.
Yes, because we have a variable that's squared. So we know it's going to be quadratic. But sometimes they don't always give us the equation. Okay? So what we'll do is we'll plug in a table. Just like we've done with linear equations, we're going to take x values that change by the same increments. Okay? And we choose x values that would be on a graph. So in this case, let's try -2, -1, 0, 1, and 2. We're going to use these x values and plug them into the equation for the x's and solve for what y would be equal to. Okay? So I'm going to quickly do that on the side here. Y equals 2, and our first value is -2. So -2 squared plus 3 times -2 minus 1. So if you notice, I've taken the -2 and I've replaced the two x values with -2 to solve what y is going to be at that point. -2 squared is what? 4 times 2? Okay. -2 times 6? Sorry, times 3 is -6. And minus 1. What are we going to get here? 1. Good. So our y value, or our coordinate, is -2 and 1. We then repeat this process to find out all of these values. Okay? That's how we'd fill out one of these charts. But let's say someone's already filled out this chart for us, and we don't actually know if it's quadratic or not. So let's say that they've gone here, -2. This would give us 0. Four, and then 14. No, 14. No, 13. Okay. So let's say they've just actually given us these values from a table. There's another way to tell if something's quadratic. So I'm going to move this over. And what we do is we find the differences in the y values. Okay? So, first of all, these are called first differences and second differences. We need to make sure that the x values all increase by the same increment. Okay? And they do in this case. They're all going up by 1 every single time. So what we're going to do for first differences, call it first diff, okay, is we're going to take our values and we're going to subtract them. So we're going to take the bottom value and subtract it from the top. This will also help us with slope. Okay? So we're going to take that -2 and we're going to subtract it from 1. What is that going to give us? -3. Good. Okay? So that's this first pairing. Then we're going to do the same thing with the next pairing. We're going to take -1, subtract -2. What are we going to get? We're going to get +1. Okay? Same idea. We're going to take 4 and subtract -1. What are we going to get? Yeah. And then we take 13, subtract 4. Okay. Now, the values of the differences in the first difference, are they the same? -3, 1, 5, and 9 are all the same number? No. None of those are the same number. Okay? Because they're not the same, number, we know that this is not linear. Okay? And I'll explain that in a minute. What we mean by that is because first differences of values, if they happen to be the same, that means something would be linear. Okay? We'd have a straight line. But these ones aren't. So this is not a linear equation. So what we do next is we test with second differences. Second differences is when we take the values of the first differences in the same pattern and go through them. So 1, subtract negative 3. What is that going to give us? 4. 5 subtract 1. 4. 9 subtract 5. Okay. Are the second differences the same?
Yeah.
Okay. If second differences are the same, that means we have a quadratic function. Spelled that over there. There you go. Quadratic function, and it's the shape of a parabola. Okay? So, in order to tell if something's linear or quadratic from a table, we do first and second differences to solve that. Okay? If first differences are the same, we have something that would be considered linear. And if they're not, we continue. We continue through, and if second differences are the same, they're quadratic. What if second differences are not the same? Is it linear or quadratic? Anyone know? If both are not the same, it would be something else. Okay? It would just be neither. Wouldn't be linear, wouldn't be quadratic. That's all we got to get to there.